In this video, we're going to be talking about angle properties. So first of all, let's look at some names of our angles. So we're going to start off with this one. We call an angle when it is bigger than this one, and it's bigger than the one that looks like this. So it's gone this far. We call it an obtuse angle. An obtuse angle is between 90 degrees and 180 degrees. Being a little bit more specifically, it's really between 90.1 degree and 79.99999 degrees. I'll explain more on that later. We then have one like looks like this, and it has a box in the corner. We call this one a right angle. Doesn't matter if it's pointing this way or this way, it's still called a right angle. And a right angle has to be exactly 90 degrees. When I'm talking about degrees, what I'm talking about is, imagine this was a clock. We have 12 o'clock, 6 o'clock, 3 o'clock, 9 o'clock. And I have my minute hand, my hour hand, whatever you want to call it, here. So we're starting at the 12. We're then going to move, and we're ending up right here. So we were there, now we're here. So we've traveled this section of our clock. So looking at fractions, we call it a quarter. Looking at angles though, I've moved 90 degrees around my circle. Alright, let's look at our next one. We have this one. To help us remember this one, we think it looks really little, and what do we say little things are? We say they are cute. We call this one acute. Acute, no. So we say acute angles are between 0 degrees and 90. Again, I'd be a bit more specific and say maybe between 1 degree and 89.99999. So it's just before it is a right angle. So acute is anywhere between, if it is like this far up, all the way to this far up, being a right angle. So it's anything in between. So an example of an acute angle could be, 45 degrees. We'll look at measuring them later. When it is a straight line, it is called a straight angle. And a straight angle is exactly 180 degrees. Just like our right angle being exactly 90, straight angles are exactly 180. So again, looking at my clock before, if I start at the 12 and I went halfway around the clock and I ended here, I've gone a straight line, so I call it a straight angle, and it has traveled exactly 180 degrees around the circle. Once we've gone past our straight line and we've gone acute, we've then gone right angle, then we've gone obtuse. Once we've gone to straight angle, and then we've gone past the straight angle, so now the circle has to reflex around. We call it a reflex angle. So it's different if the little curved line was here, because here it'd be obtuse, but we're looking at the red circle here, calling it reflex. So it's between 180 degrees and 360. But again, more specifically, maybe 180.1 and 359.99999 would be exactly a reflex. So finally, if we started at the top of our clock and we went around and ended right back at the start, we call it a revolution. And a revolution is exactly 360 degrees. We can actually also say it's worth 0 degrees as well. We could say it didn't go around the clock at all. It's just 0 degrees. So those are our different types of angles. So let's look at the properties. So if we have a straight line, we call this angle, this line right here, X and Z because of the labels on the side. So we say line XZ is straight. If you're on a straight line, we actually can work out what this angle is. So if we've been told that this angle here is worth 30 degrees, we can already tell what this is going to be without having to measure it, because we know a straight angle is what? It's worth 180 degrees. So because that straight angle is 180, it means if I put on a little angle here and said it's 30, we can actually work out what this is by all we have to do is just say 180 take away whatever we do know, which is 30, and that'll give us our unknown, which was here. So if I was just going to say this is called angle A and this is angle B, we're just going to say, well, I know the angle A is 30, so if I subtract that from 180, I'll know what angle B is. So 8 take away 3 is 5. So that means 150 degrees is what this has to be, because this right here is a straight line. Okay, let's look at another example. So we have now still a straight line. Angle AD is a straight line. And we know that we've got a couple lines coming off. So we've been told that this one here is worth 60, as you can see here. And we have this one is 70, but we don't know what this one is, question mark. So how can we work out what this mystery angle is? Well, same idea. If we get 180 and we subtract what we do know, so we know E was worth 60 and G was worth 70, whatever the answer will be the leftover, our F. If you're like me and you don't particularly like subtracting lots of numbers all together, maybe what we could do is we could say, well, 60 plus 70, we could put these two together, and that equals 130. So instead of saying take away 60, take away 70, I could just go take away 130, because that was them together. And once I've done that, I know that I've got 50 left over, which means that this mystery is 50. So this is 50 right here, and now I can put it in. So we said 60, and what I've got here is just measurement angle F. So measurement angle F was 50, which you just worked out. And then measurement G, which says it's 70, so we're at 70 here. We can do this little circle in the corner, or if you don't want to do a circle, this is a degree sign. You could do like a little apostrophe. Both of them work. So let's add them all up, and if it equals 180, we know it's straight and we know it worked. So we've got 60 plus 50 plus 70, and 0 plus 0 plus 0 is 0, 6 plus 5 is 11, plus 7 is 18. So it equals 180, and we know already that a straight line was equal to 180, so we know that it is straight, yes. So that's why we add them up, because if we add them up and we got 79, well then I know I must have made a mistake, because we were told in the question it was straight. So it has to equal to 80. That's what happens when they're on a straight line. Here we have an angle called angles at a point. You can see they all meet here. So if I call this point O, this is, I don't know, line number A, line B, line C. This is angle number D, angle E, and angle F. So all of these together, so 85 plus 120 plus 155, it all has to equal to what? Let's see. So if I again drew this as a circle, so I had the angle sort of looking like this, right? Or B was maybe a bit more of an angle. So it looks like this. What shape does it make? It makes a circle. A circle, as we said before, equal to a revolution, was worth 360. So if we look at our clock earlier, our minute hand starts at our 12, goes all the way around, and it gets to the end again, and it's worth 360. Circles are always worth 360 degrees. So with that in mind, we know all of these together have to equal 360. So let's do it. So we got D was 85, plus E was 120, plus F was 155. Add them all together. So 5 plus 0 plus 5 is 10. 8 and 1 is 9, 9 and 2 is 11, 11 and 5 is 16, 16. And then 1 plus 1 plus 1 is 3, so the answer is 360. The answer is 360, so we know that it was correct, because all of the angles added together that meet at one spot, one point, they have to equal 360 because it makes a circle, all of the angles put together. So we'll look at another example. Here's the same thing, but when we were measuring it, we made a mistake. We said we thought it was worth 150, so let's see what happens. We have our 85 plus 120 plus 150, and we end up with 355. So it didn't equal 360, but if we look at the shape, it makes a circle if we put them all together, so I know I must have been wrong. So my little person's here saying, uh-oh, they need to equal 360, some of them, when they add up to a point. So if your answer was not 360, then you know you've made a mistake, and you probably should go back in your answer and double check your answers. And here we would have realized, oh, actually, it was meant to be 355, and then the answer would equal 360 and would be correct. So let's look at vertically opposite, and then we'll look at using a protractor, and that'll be the end of this video. So I've got line FE here, and I've got line DG, and we've been told they're both straight. Both of them are straight lines. Here we have something called vertically opposite angles. So when there's either two or more, could be 3, could be 4, when there's 2 or more straight lines that cross each other, the opposite lines of things that are vertically opposite are equal. So if we were told, I don't know, this little angle here was, if I just pick a random number, I think it looks roughly like 45 almost. So it looks about 45 degrees. Then because this right here is opposite, we actually know that this is 45 as well, because they're on a straight line and they're opposite each other. So then if we had to find out what this one was, we could work it out. This is how we would do it. So, we know it's on a big circle. If I added this one plus this one plus this one plus this one, so it has to add up to 360. Right? So we've got 360 takeaway, and we know that these both are 45, so put them together as 90. All right. So then we've got 16 take away 9, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7. So 270 degrees. And we know that these both have to be totally opposite, so it means we'd have to divide it in 2 because they have to be the same. So 2 into 2 is 1, 2 into 7 is 3 with 1 remainder, 2 into 10 is 5. So I would know that this is 135 and this is 135 because they're vertically opposite. Another strategy was, if we just looked at the angle, we could ignore the bit that's bottom and just look at the top and go, well, I know this is 45, so what's this? And I could go 180, take away 45, and the answer will be 200. Should be 135. Let's see. 10 take away 5 is 5. 7 take away 4 is 3. So 135. There you go. So that was the other strategy. Hopefully that makes sense. So the idea is, if they're vertical, they're the same. If they're vertical, they're the same. If you got 134 here, we know they're wrong because it's different to the vertically opposite when they're both on a straight line. All right, final step, using a protractor. This is what we call a protractor. If we look over here, the lines on the outside go from smallest to biggest, and the ones on the inside, so we've got 0, 10, 20, 30, 40, 90, yada, 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 180, they go from right to left. So you should look closely at the protractor you have and see what direction they go. The idea is, if your angle looks like this, and I put my protractor and I move it and I put it right on you want it to meet on the corner. Obviously I can't with my program, but if I'm measuring from this, you're always wanting to measure from the straight line, right? So this bottom line right here, that always has to be on this bottom line. And if I'm measuring up to here, I'm going from here to here, right? So I'd have to be reading from the inside line, so from right to left. If my angle was like this, I'd have this line here, and I'd be measuring from here to here, so I'd be reading the outside line. So let's put it in practice and have a look. I've got my protractor. The idea is you want to, and it's a bit hard to do on my computer, but the idea is you want this point right here to be right where they intersect, and it should be on a straight line right here. Whoops. I'll be able to show you a bit better in person, but as best I can on the computer, it's got to be straight. So I'm measuring from here up to this one here, right? So I'm going from this way to this way. I'm going from left to right. So I better read the numbers that go from left to right. So 10, 20, 30. So if I drew it accurately, it would have shown it was on the 30 mark. So I'd say this one is 30 degrees. All right, keeping the protractor where it is. Now we're measuring this line here, and I'm still in the straight line, but I'm reading from right to left now. So I have to read the inner line where it goes 10, 20, 30, 40, 50, yada yada, 90. So it goes all up to 150. So my answer is 150. Now if I move the protractor away, it's very important to quickly always think, is it on a straight line? So I've got 150 plus 30, and if it equals 180, I know I've made no mistakes. So 5 plus 3 is 8. So 180 is my answer. So yes, it is, because yada yada yada, the angles added up together equal 180. So I know that XZ is a straight line. Hopefully that makes sense. If you have any questions, just ask me, and I'm sure I'll be able to help you. Remember, practice makes perfect, so it's always good to keep practicing using protractor, because it's a pretty tricky skill to learn. And another pro tip is it's always a good idea to remember back to your angle names. And if you had an angle like this, and it's acute, and your answer was 135, well then you know you've made a mistake, because acute have to be between 0 and 90. So it's always a good idea to remember what the name of the angle is and just do a quick guess. And if you said, oh, here the answer right now is 40, you go, well, I'm wrong, because it has to be between 90 and 180. And I know this is big, so it means it'd be the opposite than 40. So what, 180 take away what 40 is 140. So then, yeah, the answer would be 140. Right? Hopefully that makes sense. All the best with your work.